Hello, hopefully all of you are doing good. Wishing all a very happy and prosperous new year, advanced new year, and Merry Christmas. Now we will continue on wherever we have left off in the previous video, where we are trying to visualize how a particular single neuron works over there, right? And as a part of that, in the last video we have created this small inputs, only 3 inputs if you see, for x1, x2, x3, and a bias input. Probably in the latter part of the videos we will create a more generic input as well, but to start with we will start very small one now. And then we basically created a radio buttons for our activation function as well, and a run button, right? So whenever I will be clicking on this run, so it should display the mathematical equation. So probably I will show you here as well how it should looks like. So it should display this mathematical equation and the graph of the function as well, and then it will basically show this all these inputs and their corresponding outputs as well in a graphical format. So that also we will see. Now in this particular video we will just try to concentrate on this part, where we will try to display a mathematical equation for the chosen activation functions upon clicking on this run button, right? So if I just go to the code base on how neural network learns.py, so this is what we have done it there, right? So we basically have a callback for this one, like for single neuron or neural network on this chips callback, right? On the single neuron we have this one. We have created this x1, x2, x3, and this one, right? The activation functions list and all for the single neuron, right? Now here, if you remember, like we defined a container which is having a single row, right? And then we are having 3 columns over here. The first column we have filled up with these values. Now the second column we will fill up with the mathematical equation as well as the graph over here, right? So let's do that. So in the second column, let's create a div. So here also you can use dash maintain components stacking, or you can create a simple div as well, because this is a column, right? So if we just create 2 divs over here, one div is for the mathematical equation and another div is for this graph, it should display in the column format as well, right? So I'll just create 2 simple divs over here. So I'll just write html dot div, right? I'll just give the id as activation function equation, equation div. Okay, and for now I will just keep the children as blank array, because this children we will fill it up once we have the callback for this run button, right? So everything needs to be happen once the run button has been clicked, right? So that's why I'm just keeping it blank now. So there should be another div over here as well, right, on the graph as well, activation function graph div. I'll just name it as graph div over here. Okay, so we have the div created now. So now it is the time to create the callback for the run button, right? So what I will do is I will just copy a very simple callback signature so that we will save some time. So I'll just paste it over here. Okay, I think I have not copied it, so I will paste it over here. So I will just put a comment over here is callback for the run button here. Right now I need to check it out whether we have given an ID for the run button or not. So run button is present in the first call, as we can see it there, right? So let's give an ID over here. So I'll just give the ID as run underscore button over here. Right now, what will be my input for this particular callback? It will be the run underscore button n clicks, right? N underscore clicks n clicks. And what will be my output here? So let me remove other data. We will see it once it is required. I'll just remove the link over here as well, sorry, the list over here as well, right? And I'll keep this one as a true. So let's create that one. So once we click the run button, the first thing is this equation div, whatever we have created that div, right? So that div children needs to be updated as well, right? So that will be our initial task as a part of this video. So let's keep it simple. So what will happen, handle, I'll just name it as handle run button. Okay, and there is one input n for the run button n clicks, right? So I'll just say if n, that means if my run button has been clicked, so then I will do all these things over here, right? So first of all, I need to know first. So let me go back to the code over here. So I need to know which activation function I have selected over here, right? So based on that only the equation will be changing over here as well, right? So that means I need an input for this particular radio button input as well. So let us see that. So it should be in our this guy radio items over here. So this is the ID over here. Now the thing is, like, once I make a selection from these radio buttons, right, it should not fire the callback. The callback should be fired only when the run button has been clicked over here, right? So that means I cannot take this guy as a input of the callback. So that's the reason dash has a concept called state. So just like input and output, so there is a concept called state here. Okay, so what state basically do is it does not fire the callback, but if, let's say, if you need to access certain inputs value but you do not want to fire the callback, you should be using the state over here. So this is how I will be passing the state, something like this one, state. So I need the state of that particular radio items as well. This value I need to know it. So I'll just copy it. I'll come over here, Control V, and which property I need? I need the value property over here, right? So that's also I need it over here. Let's put a comma over here, and then I'll just say activation function. Okay, so that means this value, whatever value I'll be choosing it over here, will be come over here as this activation function. So I hope we got the difference between the input and state. So we will be using state whenever we want to use their value but we do not want to fire their callback, and whatever elements you will be using as the input of your callback, it will always fire the callback whenever it changes over there. Okay, so now inside if we are ready to see what activation function I have selected, right? So if my activation function double equals to, so we have given 4 values over here, right? Step, sigmoid, relu, and tanh. So we will handle one by one. So let us create the skeleton first. So if my activation function is step, so let's create a variable over here called activation function equation equation div content. Okay, so by default it will be blank, so I will try to put something. So we have to create that mathematical equation over here. So let us first create the content first. So else if my activation function is sigmoid, right? So this is my sigmoid function. Then also I will return something. Similarly, I'll just copy it for ReLU as well as tanh, right? So this will be for ReLU and this will be for tanh function. So this is what I have defined is as well over here, right? Now let us discuss what we need to do to basically display the equation. Now if I just go back to the Word here, so if you see, like, to display an equation, the main language is LaTeX, which is basically extensively used in academics and all, to write papers and write books and a lot of stuff you can do, and it's a very cool language to learn as well, an interesting language to learn as well. Okay, now in dash, how to display LaTeX, so that will be by my problem statement now, right? So now dash has in dash core component, there is a component called markdown. Okay, so which basically used to display the markdown. Now if you want to know what is markdown, so it's basically another language to format, or basically it has certain kind of markdown syntaxes which you can use to bold your text or italic your text. You can do a lot of formatting in your text as well there. Okay, and it has been used very extensively as well. So probably I will give this particular link as well in my video description so that you can know more about what markdown is, and I think most of you already know what markdown is, right? Now the dash core component markdown has a very interesting portion called LaTeX. Okay, so now it has a parameter called mathjax equals to true. So if you mention that, and if you mention some kind of LaTeX code over here, that will be displayed as a mathematical equation there. Okay, if you see, like over here they have given some kind of LaTeX code and they have passed mathjax equals to true, because this is the LaTeX library it is using behind the scene, and that's the version over here. Okay, now if you see it, like there are two things over here called the inline content and multi-line content. Inline content means your equation will be displayed in a single line, just like they have shown it over here. Okay, and that in that case you need to wrap it within a single dollar, as you can see it here. And if your equation has multi-line, or let's say if you want to display multiple equations, so you need to put it in double dollar over here. Okay, so that's the one thing you need to remember. Now mathjax has a really cool cheat sheet over here. Okay, so probably I will give you this link as well in my video description, so that for different cases, like let's say if you want to display x subscript 1, right? So this is how you will be doing it. X, the syntax is underscore over here, something like that, within a single dollar sign over here. If you want to, let's say, display square root, like this is the function you need to use it, backslash sqrt and the number over here, and it will display it as a square root over here. Let's say if you want to display as a fraction, right? So you want to use this one as a function over there inside this one. This is how you will be doing it, right? So let us try to create the LaTeX equation for our activation functions as well. Now for that reason I have just taken all the 4 screenshots over here for all the functions. We will display, like we will discuss about these functions later once we build the whole stuff, but for as of now let us try to build it on the fly, right? So for the perceptron, which is nothing but a step function, or we basically call it as a heaviside step function. So this is how this function works, right? This function has always value of 0 whenever x is less than 0, and whenever x is greater than equals to 0, its value is always 1. Very simple function. So this is how we will be displaying it here, right? Hx equals to, in this big curly braces, we have this one. So let us try to build that. So in our step function, which we will call the markup, right? But before that, we can always wrap it up in a div, HTML div, then children equals to, now here we will be displaying the dcc dot markdown, correct? And in the markdown, the first argument, if I just go back here, the first argument is the LaTeX syntax equation over here, the LaTeX equation over here, and second argument is the mathjax equals to true over here. And if you see this LaTeX code is getting displayed inside this 3 quotes over here, right? The multi-line string over here. So that is what we will be doing it as well. So we will be creating a multi-line string, right? And then the second argument we will be passing it over here is mathjax equals to true to display the LaTeX here, correct? Now to display this guy over here, like the big curly braces and this one, that means multiple equations over here, right? So if I just go back in the mathjax cheat sheet, so if you see this some kind of matches with this one, right? So let us try to use this one to create that step function LaTeX code. So as discussed, so okay, so what we'll do, you will mainly start with the double dollar sign here, right? So let us do that. Now inside this double dollar sign, the first thing is the hx, right? So that we can easily write using hx over here, equals to, now to create that big curly braces over here, right? So we can use this begin case and end cases over here, right? So if I just copy this one here, copy and paste it over here. Now one thing you have to remember is, because this is a backslash over here, and you need to escape that backslash as well over here, otherwise it will treat it as a different string here. So to escape it, I'll just put another backslash before it. So for each and every backslash, here we have 2 backslash, so that means 2 backslash again I have to give it over here, and this one over here, and before the end as well 1, right? So if I just save it, let's see how it looks like. So if I just go back, if I just go to model training and select the perception over here and click on run, nothing happens. Okay, I have created this div content, but I have not returned anything over here, right? So I have to return this guy as well. See if n, so return my div content here, activation function equation div content, which will be passed over here in the children as well of this div here, right? So let us see that. So if I just go to model training and click on run over here, we are able to display this equation over here, right? Now this guy has to be something like this one here. If I just go back, so 1 and 0 when x greater than equals to 0. So that means if I just see it over here, it should be 1 when x greater than equals to 0, right? X greater than equals to 0, otherwise it will be 0 when x less than 0 over here. This is how we can write the LaTeX code, right? So if I just see it now, and click on run, so we are able to create the equation for the perceptron or the set step function over here, heaviside step function over here, Similarly, let us do it for the sigmoid function. So for sigmoid function, the equation is something like this one: fx equals to 1 over 1 plus e to the power minus x. So if I just go back over here, I will do the similar stuff. I'll just copy it. I'll copy this guy over here and I will paste it over here. Now here it will be f of x. If I just see it, f of x over here, so that means instead of h of x, I'll just say f of x. And here we need to create a fraction over here, right? So let us try to see how to create a fraction in MathJX. So this is how you will be doing it. If you see FRAC, right? So I can just copy this guy over here. First I will copy this. I will remove these guys and paste it over here. In the fraction, the first part will be 1, right? So that is what we have it over here, and that is the numerator, and the denominator will be 1 plus e to the power minus x, right? Now how to create a power? If I just see it over here, it's the hat sign here. If you see, a square plus b square equals to c square, right? So if I just write something like, write something like e hat, okay, and inside the bracket minus x, this should be curly braces. So it should create the fraction over here. Again, we need to escape the backslash over here as well. So if I just save it and see it, so if I just go to model training, this time I'll choose sigmoid function and run it, we are able to do it, right? So let's do the similar thing for ReLU as well. ReLU will be very much similar. We just need to use a max function. It's basically the ReLU function. What it does is it returns you either 0 or the x value over here, okay? So let's do that. So I will just copy this code here, Control Z, copy it, and for ReLU I'll just paste it over here. So for ReLU we are using f of x equals to max of 0 comma x. It's a very simple LaTeX code here. Now if I just see it over here, there should be a max function as well, if you see it, which we need to use as a backslash of max over here. So let us do that, backslash max, and escape the backslash over here, right? Now similarly, let us do for the tan h as well. So tan h, it will be a little bit of difficult equation over here. As you can see it, like it is nothing but sin h by cos h over here, right? Just like our tan theta, and then it will be something like e to the power x minus e to the power. So this equation, let us try to create it. So we will write something like tan h of x here, right? I'll just say something like this here. So which is nothing but sin h, sin hyperbolic x, and divided by cos hyperbolic x. So that means I need a fraction over here, correct? So I'll just copy this code, paste it over here. The first numerator will be sin hyperbolic x, and then the denominator will be cos hyperbolic x over here, right? Which is, again, we have to use another equals to over here to create this equation over here. So this is again a fraction over here, as you can see it, right? So I will just copy this fraction code over here. The numerator will be e to the power x minus e to the power minus x. So we have already code for e to the power x, e to the power minus x. Let us copy that. So the numerator will be e to the power x. So that means this one, right? E to the power x minus of e to the power minus x, and the denominator will be this one, e to the power x plus e to the power minus x over here. So I'll just copy this guy. And I will paste it over here. So instead of minus, it will be plus over here. Okay. So if I just save it, and then let us try to see how it looks like. So if I just go to model training and select ReLU function over here, so we are able to display the max of 0 and x. And if I just select the tanh function over here, we are able to display this equation as well over here. So what we have learned is, we learned little bit of LaTeX as well in this particular video, right? And how to display LaTeX equation in Plotly dash page, or basically in Plotly dash app. That also we have seen it over here. How to use the dcc.markdown to display some LaTeX graph over here. Even like as you can see in the example over here, in the graph also you can turn on this mathjax equals to true, and then also you should be able to display the mathematical equation on the graph as well over here. Okay, that's a very interesting thing to know and understand as well. So hopefully this video was helpful. See you in the next video.